We're here now back again at SIGGRAPH 2016 with our next guest, Jim Blinn, who is a computer graphics, pioneer, visualization expert. I mean, you've been doing this for a long time, huh?
So the first time I started making computer images was like in 1969, I think,
1969.
Yeah, and that's back when computers were a lot smaller.
What did the images look like you were making?
They were line drawings. And
like a plotter kind of drawing?
No, it was a CRT display.
Okay.
It was a Digital Equipment Corporation PDP-9 with a 339 display, and it had the display was about this big, something like that. And you can fit maybe a couple hundred lines on the screen before it started to flicker too badly.
And that would be too hard to see it.
Yeah.
How'd you store your program?
It was in core memory, actual memory that stays there when you shut off the computer. And it was 16K of memory.
16K?
Yeah. But it was 16K of 18-bit words. Half of it was the operating system that another graduate student at Michigan wrote, and the other half was data and print programs.
But that was a big thing at that time, right?
Yeah, well, that was kind of like the state of the art at the time, and I was lucky enough to luck into being able to play with it. I was an undergraduate at the University of Michigan, and I got a summer job programming for a research project there, and they had that as part of their research project. And so when I got to use that, after the project was over and all the graduate students graduated and left with a degree, they left the computer behind, and so I got to play with that for the next 4 or 5 years.
Oh, really?
my first personal computer.
How big was that?
It was about the size of a bunk bed.
About the size of a bunk bed with 16K of memory.
Yeah, right.
Yeah. Talk about having to be efficient with your code, right?
Yeah, well, some of the language is pretty efficient compared to higher level languages.
So my introduction was in HP Basic.
Uh-huh.
And we had that, remember that yellow punch tape?
Yeah.
And then the punch cards? That's what we used for the programs that we did.
Yeah, we used punch tape on that too. There was no disk drive on it. It was just punch paper tape.
So you had that yellow paper tape?
Well, it wasn't yellow, it was gray.
Gray, huh? We had the LA Unified School District version, the yellow punch. Yeah. So what got you interested in just sort of creating images with computers in the first place?
Hard to say specifically. When I was in high school, I had no idea computers existed because they were so new. And when I went to college, I happened to have taken French in high school.
Oh, French.
And so I placed out of the foreign language requirement. And so I had an empty hole in my schedule while everybody else was taking their foreign language. So looking through the schedule, it said, computer programming, I wonder what that is. And so I took the course in computer programming. And once I realized that computers could be used to make pictures, that's what I knew I needed to do with the rest of my life.
You figured out a lot of things with your background.
I played around with the system at Michigan for 5 or 6 years. I got a master's degree there as well as a bachelor's degree. And but one of my office mates had a thesis that he was on somebody's mailing list from the University of Utah by a guy named Gordon Romney. It came out in 1970, and it had 3D pictures of color solid shapes. It was the beginning of their research there. And I kept borrowing it from my office mate to just admire the shapes so often that he finally gave it to me. And so that got me in the idea of the existence of the University of Utah as where the cool stuff was. So after a couple of years at Michigan, I applied to graduate school at Utah, and I went out there. And I got to Utah at about the time they got the first Evans and Sullivan frame buffer working. Before then, all of the 3D graphics that they did was done primarily on film. You didn't actually get to see the image until you exposed it on film and then got the film developed. And so the frame buffer was the first thing that would display a raster scan image on the screen while you were computing in it. Every time you stuck a number in the memory, the little pixel would light up on the screen.
Yeah. And you had to do it pixel by pixel by pixel, right?
Yeah. And so I started tinkering around with that, and Ed Catmull left school, and his thesis was about rendering curved surfaces, and so I sort of first implemented his algorithm and adapted that to do 3D shaded images of bicubic surface patches, and then started tinkering around with shading algorithms. And I spent quite a long time in the engineering library looking through papers on how light reflects off of surfaces, and a lot of them didn't make any sense to me, but some that did, I was able to adapt the mathematics in it to improving the surface shading algorithms that are used to color in the surfaces.
And then what about things that are deformed more or not quite so smooth?
Well, I did... you
got involved with that too, right?
Yeah, well, it was an approximation. The idea was, once you had this mechanism for drawing parametric surfaces, you could make various parameters of the surface functions of the parameter. So you can make the shininess or the color or the matte surface, and so forth, as change over the surface. But it still looks smooth. And I was trying to do some science visualization. That's one of my main interests. And I was trying to make a picture of a molecule of water. And what I wanted to go for is an effect kind of showing the electrons whizzing around. I wanted to make it look like a ball of yarn, like things wrapped around and around and around the surface. And that didn't really look too good, just making the brightness kind of change. And I was studying it and realized that the thing that makes surfaces look wrinkled is not so much the fact that they're displaced so much, because it's just a teeny amount, but it's the fact that it tips the surface slightly away from what the actual normal vector is. So I figured, well, let's see if we can modify the normal vectors as a function of the parameter to make them tip towards or away the light different. And so after fiddling around with the math on that, I came up with this idea which is called bump mapping, and that shows how to make wrinkled-looking surfaces
and that's
cheaply.
Something that everybody's using today, right?
Well, it's like I say, it's approximation.
It's a very basic part today.
When it works, it works. Yeah, and nowadays also people actually do displace the surface as a more accurate approximation. But bump mapping is a good cheat,
especially when you don't have so much system.
Yeah.
To throw at something, right?
We had a PDP-11 at Utah, which was quite a bit better than a PDP-9, but it still was way slower than computers nowadays. And it took about 15 minutes to half an hour to make an image.
And what kind of pixel resolution would that be?
It was 512 by 480.
512 by 480, it would take 15 minutes or so. Yeah.
And it was 8 bits per pixel.
How did you feel the first time you saw an image that was almost photorealistic coming out of a computer? I
don't know. It happens gradually enough so that there was never a time when, suddenly the images looked not photoreal and looked photoreal. And so I don't know if I can place a particular image that, suddenly, but first time I did bump mapping, the first time I had it work, I was pretty jazzed because, I actually was dancing around in front of the screen. The trick about bump mapping is that and a lot of computer rendering is that you figure out the math of something and you can make an image and it looks kind of okay. But if there's a bug in it, sometimes you don't notice it until you try to do animation and try to have it move around. And it takes 15 minutes to make a picture. You don't get a lot of animation out of that.
Right.
But the frame buffer had a mode where you could, instead of make it 5 by 12 by 480, you could divide it up into 16 different lower resolution images, and then it would flip through them like a flip book. And so you could make a 16-frame movie.
Of a smaller area.
And so then I used that to do it. And of course, the first time I tried it, I had a sign wrong on something. And so each individual frame looked kind of okay, but then you had it rotate, it looked like some weird optical illusion because the lighting was just kind of bizarre. So when I finally found the sign flip to make it right, then it looked so much better. It was really great.
Yeah, that's just absolutely pioneering to even imagine now when we have 4K displays and the ability just to, utilize that to think about having to take a 512 image and be able to see multiple versions in your frame buffer so you can see you got to cut it down into 16 little.
Yeah.
That shows a true love, huh?
Yeah. I used to spend nights in front of the computer starting making an image and then take a little nap underneath the table and had it ring the teletype bell when it was finished making the image, so I'd wake up and go and make the next image.
In my day, I had projects I was using After Effects from COSA when COSA first came out with it, and you'd hear the your rendering was done.
Yeah.
And you'd wake up at 3 o'clock, whatever time in the morning, to go check it out because you had to, fix whatever you did wrong,
sure,
right? And then go back and
yeah.
So you did stuff with NASA also, and the Voyager and all this. Was that much later, or
after I graduated from Utah? I started working at JPL, and actually I'd been kind of interested in JPL for a long time, except I didn't have a degree in astronomy, so I figured there wouldn't be a job for me there. So what happened was I called up Ivan Starvelin, who had also just recently left Utah to be the department chairman at Caltech.
Okay.
And so I called him up and said, "Hi, I'm just graduating and I'm looking for a job. And do you have any positions at Caltech?" And I knew JPL was a part of Caltech.
Yeah.
And so I said, to be honest with you, I will probably go out and hang out at JPL to see if I can find something interesting to do out there. And he said, "Well, that's interesting because a guy who just happened to have bought a copy of the exact same hardware that Utah had at JPL, but wasn't quite sure what to do with it. And so you can go and play with that." So his name was Bob Holtzman. So I went and signed on with him to do something useful with the graphics equipment at JPL. And at the time, the Voyager project had just gotten launched. And the guy who was the mission designer, Charlie Kohlhase, had made a line drawing based movie of what it would look like when the spacecraft flew by Jupiter and Saturn. Basically, you saw Jupiter come up and go away as the trajectory went by it. So I said, "Hey, I've been doing textured surfaces at Utah, and I'm really interested in astronomy and outer space, and guess what I'm going to do?" So it was kind of written in the stars, so to speak, that I would make this shaded movie of the Voyager spacecraft going by Jupiter and Saturn.
What year was that?
1977, 78.
78, okay.
And the first encounter was 1979, March, something like that. And so working with Charlie and a few other people, I was able to get a 3.5-minute movie made. We had the surface of Jupiter, and there were like 4 main moons that it was going to go by. But we didn't know what those looked like because they're just dots of light in a telescope. And so I had tinkered together a paint program on the thing, and we had some astronomical artists come in, use the paint program to draw kind of hypothetical maps of what it might look on the moons. So we used those as the texture patterns on the moons. And so we showed kind of roughly what the flyby was going to look like. Look at the moon, look at this moon, look at Jupiter for a while, look at the moon, and so forth. And so that turned out to be a big hit, and they basically used it as part of the PR package when the news media came. They gave copies of the film to all of the news media, and they showed it on the nightly news, something background to show while the news commentator was talking about what was happening with the real pictures coming back.
And that makes a real big difference, too, to the program, to have that kind of information, visual, people can understand what's going on, right?
Yeah.
So how long did that take you to come up with that animation, the whole thing? Basically,
when I arrived there in 1977 till 78 December, just before the mission, the first one is developing all the software to do it. A planet rendering program and a spacecraft rendering program and so forth, all merged together under the frame buffer.
People today, we just don't even appreciate how much work goes into the engines and
basically,
the 3D
I started out with a
apps.
text editor and a Fortran compiler, and that was it. So all the rendering and animation and camera control software and so forth, I had to write myself.
Wow.
But software is a lot simpler in those days to write, I think.
So what's been your most rewarding thing you've done, or the most fun thing you've worked on?
After the Voyager missions went by, I got hooked up with a project at Caltech to do animations for a telecourse on basic freshman physics. It's called The Mechanical Universe. And it was funded by the Annenberg Foundation. Walter Annenberg was the ambassador to Great Britain under Ronald Reagan. And they had something there called the Open University, which was university telecourses that people could see. And when he came back to the United States, he says, "I want to do something like that in the United States." So he set up this foundation and gave various universities grants to make telecourses on their particular specialty. Caltech's being physics, we got a grant to do a course on physics. And so I got it to do the animation for this 52 episode course covering freshman physics from dynamics to electrodynamics and relativity and so forth. And that's something I'd been kind of like studying all my life to be able to do. And I think that was my favorite project of ever, because I got to kind of refresh my knowledge of physics. My bachelor's degree is in physics. Yeah. And I got to figure out ways to explain it to the outside world. And it was a course. It was a college level course too, so it wasn't too simple. It actually got into calculus, and so I was able to figure out ways to represent that visually and hopefully teach it to people.
When I took physics, it was all based in a textbook.
Yeah,
right? It wasn't really.
Well, there have been things like
content.
That. There's always things like that. When I was in junior high school, they had some television courses on TV at 6 a.m. So I'd get up every morning at 6 a.m. and there was a course called Continental Classroom. And there was one in math and one in physics and one in chemistry. And growing up in a small town, I didn't have a whole lot of access, so I was just fascinated by that. And it was mostly somebody talking with a chalkboard and so forth, but they had demonstrations and whatnot. And so that was one of the inspirations for doing the next
taking
generation
to the next
thing.
level.
Yeah, and also there's movies like Man in Space and the Bell Telephone Science series, which were big during, came out as part of the Sputnik effect. And so I was fascinated by those as well. So I got inspired by early things and was happy to be able to do the next generation of that.
Do you remember those little Bell Telephone Labs kits you could get for science?
Yeah, I got one of those things.
Did you? I got one too. They were amazing.
It was.
Did you have one too in our audience here?
It was something
yeah,
to.
Wasn't that cool? Yeah.
What was interesting about it was that I have this odd relationship with hardware, in that it never seems to work for me. And I'm master of the cold solder joint, basically. And so the kit that I got was it was a kind of like a vocoder sort of thing. It would have a little oscillator to make a pitch, and then you have a bunch of capacitors to filter it to make performance. And it didn't work and didn't work and didn't work. And I thought, hardware doesn't work. I don't understand this. And finally, I figured out the right joint, and it worked. And I said, wow! The first thing I actually built that worked.
Those were a lot of fun.
Yeah.
Those kids, absolutely.
Yeah.
So with all this background, everything you've seen, and coming to you come to SIGGRAPH quite a bit, I imagine.
I've been to most of them, yeah.
Most of them.
Yeah.
Seeing the papers, do you attend a lot of the papers, or what's your favorite part?
Mostly is the toy store in there.
You like to go in the toy store,
Yeah.
experience all.
Yeah. And I want to hear for a couple of days, and so mostly I just go and look at the equipment and the emerging technologies and so forth.
Yeah, emerging technologies, yeah. I mean, you're looking forward to what you want to spend more time doing. Any particular area of interest?
Playing with VR looks like fun. I got the world's cheapest VR setup, which is a used Android camera and one of those Viewmaster things that I played around with a little bit. But that's something that I would like to be able to do, because what I'm interested in now basically is basic math and coming up with ways of just rendering three-dimensional graphs and being able to look at them from different directions. That'd be a fun thing to do. I mean, nothing earth-shattering. People have been doing that, but I have particular shapes that I'm interested in looking at. So.
Well, that's so fascinating, because being able to visualize the data in that kind of a way where you're actually in the environment where the graphs are, charts are, it takes on a whole new meaning, doesn't it?
Well, I'm a very visual thinker, and when I was in college, I finally realized that I was not going to learn math from math books. I would read a book and say, I don't know what they're talking about, and then I'd go and figure it out for myself and go and say, oh, that's what they were trying to tell me all along. I didn't,
You start just getting your pencil and paper here.
Yeah, and so I need to make pictures of everything. And my particular interest now is in algebraic geometry, and there's the top algebraic geometry books have no pictures in them, and there's a reason for that. Mathematicians tend to avoid pictures because there's sometimes a distraction. They can fool you, and they don't generalize to arbitrary dimensions easily, and so forth. But I still want to make pictures of all the algebraic geometry constructions that. And show what's going on more geometrically.
I think I'd prefer to have the pictures. I don't know. It's pretty hardcore, right?
Yeah.
Yeah, without it.
Yeah.
So the VR.
Yeah.
What's amazing to me is how quickly you can create an environment with the tools that are available today and move through it in a virtual space, isn't it?
Well, I haven't kept up with the tools all that much, but I've been seeing other people being able to do a lot of cool things.
Yeah, I was trying Unreal and then Unity because they're basically free for most projects until you get to a certain level. But be that as it may, I was just enthralled with, because I'm a graphics guy more, where I do production work, post-production work, things like this. And to be able to create an environment and then move through it in real time, when I've been used to rendering things for 17 days in the old time, and you see your 1 minute video.
Yeah.
How cool is that, right?
It's astonishing, being in it, closely, you see the incremental nature of it. So it's just a little better every year, a little better every year, a little better every year. So it's not some cliff sort of where suddenly, wow.
Yeah.
And so it kind of sneaks up on you. But going from half an hour per frame to 120 frames a second at 4K is quite a jump.
Have you met Doug Trumbull before?
Yeah, I did.
He worked with Stanley Kubrick on 2001 and all.
Yeah.
He was telling me that he's looking for like 130 frames a second, stereoscopic, 4K, and he says
that's just the thing. Once we figure out how to do something at a certain resolution, we say, no, we're not satisfied. We're going to double resolution. Now we're going to double the frame rate. Now we're going to have stereo. Now we're going to have high definition. So the people keep layering on more and more, more and more requirements. But sooner or later we'll run out of things to add, and we can just enjoy what we've got, I hope.
Yeah, the interesting thing was though that he was saying that in cinema there was an old rule: you don't look right into the camera and address the audience. But this is just so real; it just felt so natural to be able to make that happen. So it's exciting.
Yeah,
we're almost out of time, but let's see if we can get a few questions from the studio audience. Yep, this gentleman right here has a question. Lance?
I'm Lance. Yeah.
Okay, great.
Jim, good to meet you. So you have a very unique perspective, having seen computer graphics almost from the virtual beginning of computer graphics itself. What do you see as the challenges for the future? What sort of things is computer graphics going to bring out in the future that you would be interested in?
What's going to happen in the future of computer graphics? People seem to think that I should have some opinion on this. I'm not sure I do. It's kind of hard to find things that haven't been done yet, So now we can use it as a tool to do something useful instead of just, hey, cool pictures.
That's what's amazing to me with students, for example, coming out of universities these days. They're more focused on creation, right? Versus having to create tools to do the creations too, right? Yeah. Good question.
Hi, Jim. It's good to see you. My question is, in the immersive virtual reality realm, what do you think would be the single biggest thing we could do to improve realism with shaders, just rendering, tracking? What do you think it is?
The single thing to do to improve realism in virtual reality. I haven't had a chance to see any of them this year, but the ones that I saw last year, the one thing that occurred to me is you can still kind of see the pixels. And I think just another factor of 2 in pixel resolution would kind of kick it over the edge where that's not so much of a distraction. And of course, 18 months from now, or 18 months from last year, we're probably there now. I don't know. And so I think that was the one thing that I thought would be the best thing. Virtual reality is kind of amusing in that, it's kind of one of these things that's, next year it's going to be really there. The first virtual reality that I know of was done by Ivan Sutherland back in the 60s. And so before I got into anything, but so it's been around for a long time, and the technology has just been, big and clunky. And now that we've got cell phones that basically can do virtual reality, now we're probably going to be able to, go somewhere with it. And hopefully, the 2x of pixel resolution will do it for us. Yeah.
8K, 16K. Mr. Hamilton, any question? You're good?
Well, actually, one question. What are you doing these days?
Well, as I say, I'm interested in algebraic geometry, and so I'm reading a lot of 100-year-old math papers and trying to figure out better ways of presenting them so you can understand what they're talking about by making a lot of diagrams and color-coded images and whatnot.
Isn't that amazing? Who do you know that would do that, right? Jim, absolute pleasure meeting you.
Thanks
for
very much.
coming on the program.
Okay.
We really appreciate it.
Glad to be here.